Now next topic is differentiation. So yesterday we were discussing continuity and differentiability, and now today we will discuss differentiation. Differentiation is one such topic which students are familiar with a little bit of this in their because of their plus one. A little bit of they have done in their plus one maths and as well as in physics. But now we will discuss this topic extensively. Now we are going to discuss first of all how to differentiate using the first principle, and we are going to discuss all the formulas relating to differentiation first, then we will discuss their application. So first is by the first principle. Now first principle is, that is your, this is also called ab initio method or first principle method. So what is that? So by this method we have f dash x is equal to limit h approaches to 0 f of x plus h minus fx upon h. Sometimes it is also asked that differentiate by the delta method. So what is delta method? That is your f dash x is equal to limit delta x approaches to 0 f of x plus delta x minus fx upon delta x. So nothing much of the difference between second and third, but if it is being asked to differentiate by the delta method, this way by the first principle or by the ab initio method. Now for example, we have the function fx is equal to x raised to power n. Now we want to differentiate it using the first principle. Then you can see here f dash x is equal to, this is limit h approaches to 0 x plus h raised to power n minus x raised to power n over h. Now x plus h raised to power n means that we need to know the binomial. So this is limit h approaches to 0 x raised to power n plus nc1 x raised to power n minus 1 into h plus nc2 x raised to power n minus 2 into h square, and so on, nc n h raised to power n minus x raised to power n upon h. First term and the last term will cancel. From all other remaining terms we can take h common. So it is nc1 x raised to power n minus 1 plus nc2 x raised to power n minus 2 into h, nc3 x raised to power n minus 3 into h square plus h raised to power n minus 1, this divided by h. You can see that as h approaches to 0, except the first term, all other terms are going to approach to 0. So this is equal to nc1 into x raised to power n minus 1, which is your nx raised to power n minus 1. So this way we get the formulas, that is for the differentiation. So that is d over dx of x raised to power n is nx raised to power n minus 1. So we write down the formula, that is d over dx of x raised to power n. That means we are differentiating the function x raised to power n with respect to x, and what is the answer? Answer is nx raised to power n minus 1. Similarly, let's say consider any trigonometric function and how to differentiate using the first principle. Let's say fx is equal to sin x. So using the first principle we want to differentiate this. Now can I write this as f dash x is equal to limit h approaches to 0, this is sin of x plus h minus sin of x upon h, which is your limit h approaches to 0, because sin c minus sin d is 2 cos c plus d by 2 into sine of c minus d by 2 upon h. So it is 2 times limit h approaches to 0. This is cos of 2x plus h by 2 into limit h approaches to 0. This is your sine h by 2 upon h. It has to be divided by 2, correspondingly multiplied by 2. This 2 will cancel. So as we apply the limit here, it becomes cos x into 1, which is equal to cos x. So that is d over dx of sin x is equal to cos x. Similarly, d over dx of cos x is equal to minus sin x. D over dx of tan x is equal to secant square x. D over dx of cot x is equal to minus cosecant square x. Then you have d over dx of secant x is equal to, this is secant x into tan x. D over dx of secant x is equal to minus cosecant x into cot x. Now let's say again consider some other function. Let us say we want to differentiate fx is equal to e raised per x, that is your exponential function by the first principle. So we have f dash x is equal to, this is limit h approaches to 0, e raised per x plus h minus e raised per x over h. So can this be written as limit h approaches to 0, e raised per x into e raised per h minus e raised per x upon h. This is e raised per x into limit h approaches to 0, e raised per h minus 1 over h. Because this limit is equal to 1, this is equal to e raised per x. So that is why d over dx of e raised per x is e raised per x, d over dx of a raised per x is a raised per x into log of a to the base e here. So all these formulas can be derived using the first principle. Now next is let us consider the function fx is equal to log of x to the base e. So you can see here f dash x is equal to, this is limit h approaches to 0, this is log of x plus h to the base e minus log x upon h. This is equal to limit h approaches to 0, this is your log of x plus h upon x to the base e upon h. This is equal to limit h approaches to 0, this is your log of 1 plus h over x to the base e upon h. Now because limit x approaches to 0, log of 1 plus x over x is equal to 1. So therefore it is h over x, it needs to be divided by x, correspondingly multiplied by x. Since the variable is h, x being constant outside the limiting sign, so limit h approaches to 0, this is your log of 1 plus h over x upon h over x. So this is equal to 1 over x. So that is d over dx of log of x to the base e is 1 over x. D over dx of log of x to the base a is 1 over x log of a to the base e. Now next is, these were the standard formulas. Let's say we want to differentiate any function, particularly let's say it is e raised per x square, using the first principle. So f dash x is equal to, this is limit h approaches to 0, e raised per x plus h whole square minus e raised per x square upon h. So this is equal to limit h approaches to 0, e raised per x square is common, e raised per x plus h whole square minus x square minus 1 upon h. Now this is constant, so it is e raised per x square into limit h approaches to 0, e raised per, what is that, it is x plus h whole square minus x square minus 1 upon x plus h whole square minus x square into x plus h whole square minus x square upon h. Why? Because limit x approaches to 0, e raised to x minus 1 over x is equal to 1. You can see that as h approaches to 0, it becomes e raised to 0 minus 1 upon 0. Now, so this is equal to e raised to x square into limit h approaches to 0, e raised to x plus h whole square minus x square minus 1 upon x plus h whole square minus x square into, this is limit h approaches to 0, x plus x into x plus h minus x upon h, this will cancel. So it becomes e raised to x square into 1 into, as we apply the limit here, this is 2x here. So this way we can differentiate any function using the first principle. Now next is so how to differentiate using chain rule, or how to differentiate the functions. So the first one is, let's say y is equal to sine of x square plus 1. So we have to differentiate this function using chain rule. Now let x square plus 1 is equal to u. So therefore y becomes sine of u. So sin x, cos x, tan x, etc., e raised to x, log x, a raised to x, they are all basic functions. Now the angle is not x, it is x something different. So we want that it should be a basic angle. So that's why whatever is the angle, you replace it with the, say, linear angle. Let's say this is your u here. So therefore dy over dx is equal to, what is that? Dy over du into du by dx. Now dy by du means d over du of sine u into d over dx of u, which is your x square plus 1. So differential of sine u is cos u and differential of x square plus 1 is 2x, which is your cos of x square plus 1 into 2x here. So this way you can use the chain rule to differentiate the functions. Or otherwise, what is the other way out? Other way out is, we have y is equal to sine of x square plus 1. So what is dy over dx? This is your d over dx of sine of x square plus 1, which is your cos of x square plus 1 into d over dx of x square plus 1, which is your cos of x square plus 1 into differential of x square plus differential of 1. What is that? It is cos of x square plus 1 into 2x here. So you can use any method to differentiate the function. Your differentiation should be very strong because all the topics from this onward are based on differentiation. Application of derivatives, higher order derivative, integration, indefinite, definite, then area under the curve, then that is your differential equation. So all these topics are based on differentiation. So differentiation is one such topic where you should be very, very particular, very regular about this. Now next is, let's say we want to find the differential of y is equal to sine of e raised to power x square. So what is dy over dx? This is d over dx of sine of e raised to power x square. Differential of sine is cos of e raised to power x square into d over dx of e raised to power x square. So what is that? It is cos of e raised to power x square into e raised to power x square into d over dx of x square. Because why it is this? Because differential of e raised to power anything is same, but here it is not x, it is x square. It again needs to be differentiated. So it is cos of e raised to power x square into e raised to power x square into 2x. So this is the answer here, right? Now next is, for example, we want to differentiate y is equal to sine cube x. It is not sine x. it can also be written as sine of x and its whole cube. So how to differentiate this? So dy over dx is equal to d over dx of sine x and its whole cube. So can this be written as, it is of the form now x raised to power n. You cannot straightway differentiate this because first it is of the form x raised to power n. So it is n times x raised to power n minus 1 into d over dx of sine x. So what is that? 3 times sine x raised to power 2. Now the differential of sine x is cos x. That is, it is 3 sine square x into cos x. So this is the differential here. Now next is, say we want to differentiate y is equal to sine inverse of a plus b cos x upon b plus a cos x. So before discussing this, let me tell you what are the differentials of the inverse trigonometric functions. So d over dx of sine inverse of x is 1 over under root of 1 minus x square when x belongs to minus 1 to 1. Now d over dx of cos inverse of x is minus 1 over under root of 1 minus x square, again when mod of x is less than 1. D over dx of tan inverse of x is, what is that? It is 1 over 1 plus x square and when x belongs to R. And d over dx of cot inverse of x is, that is your minus 1 over 1 plus x square when x belongs to R. Then you have d over dx of secant inverse of x is 1 over mod x into under root of x square minus 1 when mod of x is greater than 1. And d over dx of cosecant inverse of x is, it is minus 1 over mod x into under root of x square minus 1 when mod of x is greater than 1. So these are the differentials of inverse trigonometric functions, and these formulas are also derived by using the first principle. So coming to this question, can I write down dy over dx is equal to d over dx of sine inverse of a plus b cos x upon, that is your b plus a cos x. Now differential of sine inverse is 1 upon under root of 1 minus a plus b cos x upon b plus a cos x whole square into d over dx of a plus b cos x upon b plus a cos x. So this way we are going to differentiate the present function here. So can I write this as 1 over under root of, this is b plus a cos x whole square minus a plus b cos x whole square upon, because b plus a cos x, so it will go there, b plus a cos x into, what is that? U upon v, because d over dx of u into v is u into differential of v plus v into differential of u, because d over dx of u upon v, this is v into differential of u minus u into differential of v upon v square. Why I have written all these formulas straightway? Because you must have done in your previous classes, that is your plus 1. Now into, so what is that? It is b plus, no I am not going to, I cannot complete this question here, so I am going to solve it here. So taking this to here, so it is 1 over under root of b plus a cos x square minus, this is a plus b cos x whole square, and here it is b plus a cos x into b plus a cos x into differential of a plus b cos x minus, so what is that, a plus b cos x into differential of b plus a cos x upon, what is that, it is b plus a cos x whole square. You can see that this factor will cancel. So what next? It is 1 over under root of b square plus a square cos square x plus 2ab cos x minus a square minus b square cos square x minus 2ab cos x. Now this term will cancel into what next? It is b plus a cos x into, because differential of a is 0, it is minus b sin x minus a plus b cos x into differential of b 0, it is minus a sin x here. After that it is merely calculations and we need to simplify this. It is minus b square sin x minus ab sin x cos x plus it is a square sin x plus it is ab sin x cos x. This term will cancel upon, what is that, it is b square into 1 minus cos square x minus a square into 1 minus cos square x. So if I take minus common from the numerator from the two terms, it is b square minus a square into sin x upon under root of b square into sin square x minus a square into sin square x. Now again I can take sin square x common from the square root, it is minus b square minus a square into, that is your sin x upon under root of, this is your b square minus a square into sin x. Now you can see from here, in all these cases this term is also going to be there, b plus a cos x from here, now into b plus a cos x from here, now into 1 over b plus a cos x from here, into 1 over b plus a cos x from here. This will cancel, so it is minus under root of b square minus a square upon, this is b plus a cos x here. So this way you can differentiate the function here. Now next is, for example, we want to differentiate log to the base 7 log to the base 7 of x. We want to differentiate this. Now first of all, which formula I am going to use here is, you can see that because d over dx of log of x to the base a is 1 over x log of a to the base e, which means that d over dx of log of x to the base 7 to the base 7 is 1 over log of x to the base 7 into log of 7 to the base e into the differential of log of x to the base 7. Because if I compare it with the above one, this whole is x, so that is 1 over log of x to the base 7 into log of 7 to the base e into differential of log of x to the base 7. So it is 1 over log of x to the base 7 into log of 7 to the base e into 1 over x log of a to the base e. This is the differential there. Similarly, let us consider another function. Say we want to differentiate y is equal to log of x plus under root of what is that? It is x square plus a square. So this is the function. So dy over dx, it is d over dx of log of x plus under root of x square plus a square. Differential of log is 1 over x plus under root of x square plus a square into differential of x plus under root of x square plus a square. So it is 1 over x plus under root of x square plus a square into differential of x plus differential of x square plus a square raised to power half. So it is 1 over x plus under root of x square plus a square into 1 plus half of x square plus a square raised to power half minus 1 into differential of x square plus a square. So it is 1 over x plus under root of x square plus a square into 1 plus 1 over 2 times under root of x square plus a square into 2x. So I am taking this step to next step to this place. You can see that it is 1 over x plus under root of x square plus a square into, what is that? It is under root of x square plus a square plus x upon under root of x square plus a square, which is your 1 over under root of x square plus a square.